Alrighty, welcome back to Maths. Today we're looking at 16A, we're looking at normal distribution. So first thing we need to have a chat about with the standard normal distribution is having a look at what it looks like. So what you'll see here is the standard normal distribution graph. Notice it's symmetrical in nature. So from here, it's the same on both sides. It kind of looks like a bell, so that they'll often talk about a bell shape with these. And we can also talk about what the actual function for the standard normal distribution is, which is located here. Some other things that we can talk about with standard normal distribution is the mean, which is obviously the center, and we can also talk about the standard deviations. With these things, as we said, summing it up in this bubble box here, we've got the function for the standard normal distribution, also known as a probability density function, and these have a normal distribution with a mean, which here is the symbol is denoted as mu. So the mean is equal to 0 in the middle, and the standard deviation, which is denoted with the symbol sigma, is equal to 1. From now on, obviously in this exercise, what's going to happen is this function or standard normal distribution will be denoted by the random variable z. Now, more generally as well, you can have an additional rule whereby there's some transformations that can take place to the normal distribution. Really what we're talking about here is obviously the location of the curve, whether it's moved translated left or right, and also we can talk about the steepness of the curve, how high it goes up. To talk more generally about the normal distribution, there is a rule that you need to know, and it builds upon the original function, and you can see here it's got some additional variables. It's got that the sigma here, and it's also got the sigma here and also mu up here. So what we're saying is the mean and also the standard deviation are going to change how that looks. The additional part here is if you're asked to calculate the probability of x being less than or equal to a, it's actually equal to the probability or the probability of z being less than or equal to a take away mu divided by sigma. So taking away the mean, dividing by the standard deviation. These are some important dot points to note. When we're talking about probability density functions, the probability actually corresponds to the area underneath the graph or the curve. And if we think about the total bell curve, that total area under there is equal to 1. Some additional properties, because it's symmetrical and it is bell-shaped, that center bit is determined by the mean of the distribution, which I kind of alluded to before, and the width is determined by the standard deviation of the distribution. Alrighty, so again, let's have a look here. We've got a bell curve. You'll notice that the height of this standard distribution is 1 over sigma square root 2 pi. So this will tell us how high it is. So if you've got different sigma values, obviously that's going to change the height. On the other hand, the location of the curve, whether it's moved left or right, is going to be determined by the mean. Okay, so they're saying here, for example, we've got a mean, this might be at 1. Here we've got another mean, this might be 2. You can see it's moved to the right in this particular case. If we're talking about the two of these, the mean of this one is greater than the mean of the one on the left here. The other part to note is the standard deviation determines the height. Both of these have the same height or the same steepness, so you'll notice they are equal to each other. It's the mean that's changed. On the other hand, if we look at this one here, you can see the center or the mean is the same. So all of those are the same for both of these. However, the steepness has changed, and that's because that sigma value has actually changed on both of those. Alrighty, yeah, so the standard deviation has changed. Now, if we're going to look at this in some questions here, it's important to note for the next questions we'll be using this particular general function here. So, it says on the same set of axes, sketch the graphs of the probability density functions of the standard normal distribution and the normal distribution with a mean of being 1 and a standard deviation of 1. So here is your normal standard distribution or normal distribution, and obviously we've got it in blue sketched here. We know, obviously, in this particular case, the standard deviation is 1, the mean is 1. So we're going to plug in those mu and the sigma values into this particular rule here, and it will tell us what the function is going to be. So doing that, obviously there's the sigma at the front here, which is 1. X take away mu over sigma, take away 1, and that's over sigma, which is 1, so you don't need to do it. Here we've got the function, and you can see how it's being sketched. Next one, again, we've got the mean of being 1 and the standard deviation of being 2. Okay, so in this case, the omega comes out the front here. Sorry, not omega, the sigma comes out the front here. That's going to be the 2. And up here in this power bit, you've got x take away the mu value divided by sigma, as you can see here. Again, once you've got those in there, you could sketch it on your calculator to help you with it. But essentially what's happening is this graph is going to be dilated from the y-axis by a factor of 2 and from the x-axis by a factor of 1/2. Also, it's translated 1 unit in the positive direction of the x-axis because the mean is shifted from 0 to 1 here. So that does the translation as well. Alrighty, thank you for listening up. Bye for now.